For this week's Analytics in Action, I wanted to use an article that was published yesterday about the association of using marijuana while a woman is pregnant with the outcomes of the child in a number of psychological tests. In general, I don't like to use the healthcare examples for this class because a lot of statistics is shown around healthcare and not in a business context, but I think this one's really interesting, and there are a couple of things that we can identify and take a look at. All right, so what they did was they took data that was already collected about 11,449 children, of whom 655 were exposed to cannabis prenatally, so when they were prenatally. And then it goes through and it talks about some of the outcomes. So in the results, you can see that they're providing information for us to understand the spread here of the total data set. Half of the people are boys, and 5% were exposed to cannabis prenatally. This is kind of interesting. It talks about whether or not the exposure was with or without parental knowledge. So this would be before parental knowledge, so women who smoked marijuana before they knew they were pregnant, and then 2.1% used marijuana after they knew they were pregnant. And what they find is that using a mother using marijuana while she's pregnant is associated with negative outcomes for their children. And they conclude that cannabis use during pregnancy should be discouraged. Right? This all seems like pretty conventional wisdom here. Just in the same way that women are discouraged from smoking cigarettes or drinking alcohol during pregnancy. But what I wanted to come down and look, so there's a statistical analysis. They used a package called R for statistical computing. We've talked about that a couple times in class. It's a really nice tool for being able to do statistics. And they're starting to report things here that we are familiar with. You can see a T value and a P value, so things like actually being reported in real life. But I wanted to come down and look at the chart. This is the same thing. This is the PDF version. All right, so these are the characteristics of the children. What they're trying to show in the initial part is that there's not any difference in the children, right? So boys and girls, about the same. Here, talking about problems, you can see the number count in parentheses. And this is the page we want. Let's see if we can turn this sideways. So they're reporting here a p-value. So this is less than 0.05%. So these are statistically significant. And we also get the confidence interval. So this B is a coefficient. We'll talk about that when we talk about regressions. But they're trying to provide information on the range and the p-value. But what's really important in all of this is after we look through it all, let's flip this back. You can see they're providing range to compare these different groups. Is that the actual variance in so the model, while it is statistically significant, only explains a little bit about the different outcomes. So it's called the R-squared value is around 1.9%. Let's see if I can find 1.9. Why is it showing this? Yeah. So prenatal cannabis exposure explained less than 1.9% of the variance in outcomes. So there are 98% of other factors that are not explained here, that are not explained by the prenatal marijuana use. That could be overall values or income, diet, those kind of things. Explain a lot more about how kids end up than whether or not their mother smoked marijuana. But all of the metrics here are statistically significant. So part of that is driven by a large sample size. And that as your sample size gets larger, it's easier to find differences in things and be able to say things are statistically significant. But this will definitely be used as evidence for why marijuana should not be made legal in different states, because this article published in the Journal of American Medical Association said that smoking marijuana while pregnant is not encouraged. Well, that was pretty interesting. This was published yesterday.